Okay, so we're going to start with solving equations. So we're really just going to focus on pretty simplistic equations for the most part, and then we're going to build from there. So as a reminder, we were talking about expressions. We also talked about equations. So an equation is a number sentence that says that an expression on either side of the equal sign represent the same number. So what that means is that we expect this to actually be equal to -1. We expect that this, oops, went a little too far, that this expression right here should be equal to this one right here. We just have to figure out what x makes that happen for us. Things that are not equations, if no equal sign, then it's just an expression. If you contain some sort of inequality sign, so it'd be this sign, or this one, those are all inequalities. Okay. So we want to determine whether these equations are true or false. Sorry, that's such the solution on the other side. So just to determine if they're true and false, we just make sure that this side equals this side. So 4 plus 6, in fact, does equal 10. 10 does equal 10. This is a true statement. 8 minus 3, does that equal 4? 8 minus 3 is 5. So we're saying that 5 should equal 4. Well, this is not true. So, or you could say false. And then for C, well, it could be true for the right value for x. So this is neither true or false. Because what we see here is, well, we pick the right number. Like if x is 12, it would be true. It would be false, however, if x was, 13. Then it wouldn't be true anymore. So that's why it's neither, because we don't know what x is, and that leaves it a little ambiguous for us. So what we had done earlier when I said x would be equal to 12 is when it'd be true, that was actually a solution. So the replacement for the variable that makes an equation true is called the solution of the equation. The set of all solutions is called the solution set of the equation. For us right now, for the majority of these problems, until we get to a certain spot, you are going to have just one solution, but there are equations in the future where you could have multiple solutions. So if we have one solution, multiple solutions, whatever we write down, that's our solution set. So when we find all the solutions, we can say that we have actually solved the equation at that point. So for an example, 2x squared plus 1 equals 9. This is actually true if x is 2, because then we'll have a -2 squared, which is 4 times 2, plus 8, which is 9. Or if x is equal to 2, because 2 squared is 4, times 2 is 8, plus 1 is 9. So these are both solutions. Therefore, the solution set is this. So our solutions are -2 and -1, and our solution set, we write like this. So we're going to talk a little bit more about sets later, but right now, like I said, we're just going to call that our solution set. To determine if a replacement for a variable is a solution, we would have to evaluate the expression or expressions, if we have multiple we have to look at, for the variable replacement. If both sides of the equation are true for that variable replacement, then it is a solution. If both sides are not equal to each other, it is not a solution. So as a quick example, we would determine if 8 is a solution to this. So what we're saying is that x is equal to 8. So just like a value in equations, I'm going to replace my x here with this 8. So So I'd have 8 plus 12 equals 21. Well, 8 plus 12 equals 20, not 21. So because this is not true, that would mean that x, there we go, sorry. Probably need this little word here. So this is false. Therefore, x equals 8 is not a solution. So equations with the same solution set are called equivalent equations. So this here, a solution is 6. And if you're not sure, you just go 3 times negative 6 plus 5 is equal to, replace that x with a negative 6 minus 7. We'll see if that's actually true. So we would have a minus 18 plus 5 here, negative 6, negative 7. That will be negative 13. Negative 18 plus 5 is negative 13, negative 13. True. So that means that x is a solution. Just to throw that in there. We're not going to check this every time. I'm just showing you again. So no, we do know that one is a solution. However, this is also a solution to this equation. So 2x plus 7 equals negative 5 is true as long as x is equal to negative 6. So what we say is that these two equations have the same solution set. It means all the same solutions. In this case, you only have to worry about one. But because they have just the one solution to both of them, and it's both negative 6, that means that we call them equivalent equations. And being an equivalent equation, one of the things we know about that, essentially what this means is that I can manipulate things, and I can rewrite one equation to look like the other. And it's actually equivalent equations is what we use to solve equations. When we're trying to find a solution set, we just keep looking for equivalent equations until we have one that makes it easy for us to solve. So the addition principle, this kind of seems a little silly, but just to go through it, these are principles. So for any real number A, B, and C, if A and B are equal to each other, this is the equivalent of, then that also means there's the equivalent equation, which is that A plus C equals B plus C. So those are equivalent. So one way to look at that is that if I had said that x equaled 8, if I add 4 to both sides, that has to be the same number. X plus 4 would equal 8 plus 4, or 4x equals 12. So all of these are equivalent equations. There's an I there. I was like going, one of those letters is not right. So equivalent does not exactly mean the same thing as equal. To be equal means to be exactly the same. To be equivalent means kind of like they're approximately the same. The addition principle can help us solve equations. So if we had x minus 3 equals 5, well, that also means that I can take this. So we have an expression here, an expression here. And what I can do is that I can add 3 to both sides. And that's still equivalent. And when I do that, well, x minus 3 plus 3, so the minus 3 and the plus 3, they disappear, and I'm just left with the x by itself, and 5 plus 3 is just 8. This is also equivalent. And it's the solution. So we're going to use equivalent equations again to solve this. So what we usually do is when I want to solve, your first step should be to do what you can. So when you're solving, what you're really trying to do is just isolate your variable. So to solve, we want to isolate variable or rewrite expression. So variable is on one side, and everything else is on the other. Of equal sign. So that's really what it means to solve. So what we have here is that if I have x plus 6 equals -9, when I'm being asked to solve, I'm being asked to manipulate this so that x is by itself. So because I have this plus 6, I can just subtract 6 to get rid of it. But to keep it equivalent, I have to subtract it from this side as well. So then x, these 6's cancel out, and we have x here by itself. -9 9 6 is a -15. And this would be my solution. And now I can say equation is solved. I have to go back to that. So technically, once I find my solution, I should check it. So the original equation was x plus 6 equals -9, which means I should put that -15 back in to see if it's actually true. Just a way to check to make sure we did it correctly. So on your worksheet, so this should be a new worksheet because this is a whole new unit. You should have the number 1, you should have these two equations on there. So pause this for a second and work on those two equations, and then we'll come back and solve them. Okay, so both these equations are pretty close to each other. We want to get this x by itself, and we have a -4. So the opposite of subtracting 4 would be to add 4, which means I also have to add 4 to this side, so it's equivalent. And now we can say, well, we have x by itself is equal to, because that -4 and 4 turn into a 0, that's gone, is equal to 9. Here we have x plus 4 equals 5. So because we have plus 4 here, we are going to subtract it to cancel it out. So we're just using the opposite operator. Those cancel. And we're left with x here on this side, just 1. So for A, the solution is x is equal to 9, and for B, the solution is x is equal to 1.